Welcome back. This is the 2024 derived grade exam at TGC for level 2 chemistry. This is the bonding paper and this is question 3, which is our thermochem question. So the first one says I need to circle a word, and make sure you do circle one, and I give a reason for my circling. So I've got a piece of magnesium, I've put it in acid, blah 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 blah, temperature increases, exothermic. So I'm going to say if the temperature increases, this reflects heat being released from the reaction to the surroundings, therefore an exothermic reaction. Okay, and this one is an equation with a delta H positive. So I'm going to do that. Delta H positive means energy has been absorbed, and this is an endothermic reaction. Okay, next question. So I've got solid iodine undergoing sublimation to form gaseous iodine. So sublimation is going from a solid to a gas, so that's obviously putting energy in, so it's going to be endothermic. And I need to draw and label an energy diagram. So endothermic is going to start down here. Now this one's slightly different to the ones we've often done in class, because it's not a chemical reaction, it's a physical process. So some of you may have wanted to draw one like this, but this reflects activation energy, which is when we're breaking before we reform, break the reactants, reform the products. So that is not what we're after here. This is a physical process, so we're just looking at something like this. So I want to put I2 solid there, and I want to put I2 gas there, and delta H will be here. Be careful with this, make sure it's pretty precise. Goes to that line there, it'll be positive. And I think that's about it. There's not much more you can write in that. That's the answer for that one there. So let's now go over the page where I presume we'll have some calculations. Right, let's look at this one. Calculate the amount of heat energy released, so that's telling me it's going to be negative, when 255 grams is completely combusted. As soon as I see grams, I'm going to turn it into moles using my N equals M over M. So my mass is 255 grams. And if you forget which one is which, please take a look at this. There's the big M. That one must go down there. And this equation is on your resource sheet. So 255 grams over 32 grams per mole. And I just need to get my calculator out. And that gives me 7.969 moles. Right, so once I've done that, I need to have a look at this equation here and see what it tells me. This is the chemical I'm interested in, this chemical here. So from the equation, I know that 1 mole of N2H4 is going to release 572 kilojoules. Right, so if 1 mole releases 572, I've got 7.969 moles. So I'm going to expect that to release about 8 times that. So I'm just going to make sure that I check my answer for being sensible. So I multiplied 1 by 7.969. So I'm going to multiply 572 by 7.969. I've got that here, times 572 equals. So that is 4,558, and it's 4 sig figs, or 4,560 kilojoules released when 255 grams is combusted. Right, so that's that one. And this one's going to be slightly different. So we've got a different equation. And this one we don't start with a mass, we have to end with a mass. So if we need to end with the mass, we're going to have to start with the equation. We're also looking at hydrazine in this one. So from the equation, I'm going to start here. From the equation, I know that 2 moles of hydrazine releases 1,048 kilojoules. So I'm going to actually divide that down to 1 mole first. And so I'm going to divide that down to 524 kilojoules. So I'd always want mine in 1 mole per how many kilojoules. Okay, so then I want to go back up here. There's my other number here. So if 1 mole releases 524, how many moles will release 1,048? So I've got to get a little multiplier in here. What do I multiply that by to give me, 1,450. That was a mistake. I copied the wrong number down. So let's back up the truck here. Okay, 1,450. Okay, so what did I multiply 524 to get to 1,450? It's going to be just under 3, 2 point something. So let's just work that out. It is 1,450 divided by 524. That is 2.77. So I had to multiply that by 2.77. Therefore, I've got to multiply that by 2.77. So that is actually going to be 2.7 moles releases 1,450 kilojoules. So I've just got to check, does that sound about right? So I've got 2 moles releases 1,000, and I've got 2.7 something releases 1,450. That seems reasonable. Okay, so now I need to go back and calculate the mass. Mass equals number of moles times molar mass. So my number of moles is 2.767 times my molar mass, which is 32 grams per mole. So I'm just going to go back to my calculator and multiply it by 32, and that gives me 88.55 grams, and I'm going to round that to 3 significant figures. 88 point, oh, I rounded that there. So if I looked at this here, I'd go 88.5 because this next one's a 4. So I'm going to go 88.5 grams to 3 significant figures there. Make that a 4. All right, that's that answer done. And I think we've only got one more question here, and this is the bond enthalpy question. So this one is, that was a nice close-up of my fingers. We have to calculate the bond energy of the end-to-end bond. So we've got an equation, right, and we've got a enthalpy change, and we've got some bond enthalpies. So I'm going to set mine out like this: bonds broken and bonds formed. Okay, and I'm going to work out what bonds I break and what bonds I form. So there's my N2H4. So I've got one N to N, and I've got 1, 2, 3, 4 N to H's. Here's my O2, and I've only got one of them. So I'm breaking 1 times O to O. On the bonds formed on this side, I've got 1 nitrogen. So I'm going to break 1 N triple bond to N. Form 1 N triple bond to N. And then I've got 2 moles of water. And I know for 1 mole of water, I would break 2. So I'm going to break 4 times O to H. So what I've done now is I've just really worked out what bonds I've broken on the left-hand side and what bonds I've formed. Now I'm going to put the numbers in. This is the one I'm trying to find, so I'm going to call that X. 4 times N to H is 4 times 391. So I'm actually just going to do that here. Right, so 4 times 391 equals 1564. and 1 times O to O is 498. That's from the table in there. So I could add all those up. So I've got 1564 plus 498. So what I've got here is 2062 plus X. Over on this side, 1 triple bond equals 945, and 4 O to H's is 4 times 463. Let's just do that. Whoops. 4 times 463, it's 1852. And that total is 2797. Right, and if we use our data sheet, we will see that the delta H equals the sum of the bonds broken, subtract the sum of the bonds formed. Right, so let's substitute our numbers in here. We have the delta H. This is what most people forget. It's given to us way up there, and that's negative 572. So negative 572 equals the sum of my bonds broken is 2062 plus X, and I'm going to subtract the sum of my bonds formed, which is 2797. So what I need to do now is do the maths here. So I am going to get all the numbers together. So negative 572, and I'm going to subtract 2062 onto that side. So negative 572 subtract 2062 equals. So that gives me negative 2634 equals X minus 2797. And then to get rid of this number, I'm going to add it to the other side. So plus 2797 equals, sorry about that. And so X is going to equal 163 kilojoules per mole. So I'm just going to look to see if that's reasonable. That is, I'm looking for a bond enthalpy. It must be positive. And look at the numbers. Yep, that's not too far off these ones I've got here. So I'm quite happy with that answer. Is that it? Yes, fabulous. That's the end. Hope you did well and got what you deserved according to how hard you worked. And see you in class.